Hello everyone. Very quick video today. We're going to go over Leetcode number 225, implement stack using queues. So there are a number of solutions to this problem, but I'm just going to be going over the most optimal one. So just to give you a background, we're supposed to basically implement a stack. And this stack has push operations, pop operations, top operations, and empty operations. Now, they said that we have to use two queues in order to do this, but our solution only uses a single queue. We're going to go above and beyond. Also, some very important things to note. Depending on your language, queues may not be supported natively. So in Python, at least to my knowledge, I don't know of any pure implementation of a queue. So we're going to be using a deck to simulate a queue. Now, the only things you can do in this queue are push to back, peek or pop from front, size, and is empty. That's the only thing you can do. Now let's go over the most optimal solution. So we need an example to work with. Let's say we're going to insert 1, 2, and 3 onto a stack. Well, stacks are last in, first out data structures, so it would work something like this. And when we try to pop all of these out, it will be 3, 2, 1. So very nice for reversing sequences. But if we were trying to implement this using queues, we would run into a problem, because queues are first in, first out structures. So enqueuing something would look more like this: 1, 2, and 3. Dequeuing would only start from the front of the line, so we would basically get 1, 2, and 3 back out, when we should be getting this. So we need something a little more complicated, a little more creative to solve this problem. What are we going to do? Well, the main problem is that when we're popping stuff out, it just comes out in the wrong order. So if we were, for example, pushing 3 or enqueuing 3, we can't just dequeue it right at the beginning, because this 1 and 2 are in the way. So what do? Well, let's just simply remove them. Let's push them out of the way. So we're going to dequeue whatever's in the front, and then we're just going to enqueue it to the back. So it's going to look like this. We're going to do removal of 1 and enqueuing of 1, which results in 2, 3, 1. Now 3, which is what we want, still isn't at the front, right? Because we want 3 to be removed first. So we're going to do that one more time. Remove 2, push it to the back. 3, 1, 2. Now we have what we want. 3 is going to be at the front. And this is good. So this is basically the gist of our algorithm. Every time we're pushing an element into our queue, or enqueuing, it's really the same thing in this context. Anytime we're going to be enqueuing something into this data structure, we're going to make sure that everything in front is going to be dequeued and enqueued to the back again. This way, we're going to ensure that the most recent element we push onto our stack is going to be at the front of the queue, which means it's going to come first, which follows last in, first out. And that's basically it. So let's get to the code. We just want to import some things first, namely our deck class. And we're just going to have one queue. And in this push operation, at first, we're going to just enqueue the element as if nothing special is happening. So self.queue.append x. And then we're going to say while self.queue 0 does not equal x, meaning the last thing we pushed isn't the first thing at the top of the line or at the front of the line, then we remove whatever's in front of it. We're going to say self.queue.append self.queue.popleft. And that's basically it. For the pop operation, it's very simple. We're just going to do self.queue.popleft. Why? Because we're guaranteed by the way we designed this push operation to have whatever the last element that was pushed onto the stack is guaranteed to be at the front of the line. So we just pop left. And this is very similar, except we don't pop left, we just access it. So we just return 0th element. Of course, we return this too. And then, this is very simple, we just check if the queue has any elements in it. Now let's see if it works. Okay, so this is the single queue solution. If you like this video, please like, comment, and subscribe. Thank you.